what I want to get is I want to get a 0. I want to get a 1 over delta t, right? To cancel with the delta t, I want 0 and 0, right? So, okay, let's just, because of this 1 over delta t, I actually want to multiply both sides by delta t. So the equation I actually want to solve is 0, 1, 0, 0 is equal to that matrix times C1 delta t, C2 delta t, C3 delta t, and C4 delta t, right? So that's the system, and I think we did this last time. A equal to, I think I lost the history. A equal to 1, 1, 1, 1, 1, 0, minus 1, minus 2, half, 0, half, 2, and a sixth, 0, minus a sixth, and 4 over 3. Oh, minus 4 over 3. Okay. And I just a backslash my right hand side 0, 1, 0, 0. So that's the coefficients I get. This is my C times delta t. And the scheme I derived, therefore, is therefore du dt is going to be approximately equal to, I'm going to write 1 over delta t here, because all the coefficients I derived is c times delta t, right? Which means c is going to be all of these numbers I got in MATLAB divided by delta t. So the first is a third. It's going to be a third of u times t plus delta t. And then I have plus a half of u t. I think I get a minus of 1 times u t minus delta t, right? And plus a sixth, right? If I multiply by 6, yeah, I get 1. That is u of t minus 2 delta t. Okay. Is it pretty clear that we can turn this into a scheme?